Hey guys, this is John Rovira, and this is my quarterly update sprint video for the spring of 2016 for my project Pattern Matching. So the goal of my research is to help front-end web developers build complex front-end components better, faster, and with more confidence. Without a proper amount of guidance or relevant background development experience, learning front-end developers who understand JavaScript but have minimal experience developing components have trouble creating components that scale well, operate efficiently, and provide unique interaction affordances. So to meet that end, currently the most popular resources for learning to build web components are tutorials. Based on initial need finding surveys that I did, however, there are a few problems with that option. While offering correct solutions, the code that these tutorials present rarely takes scalability, unique functionalities, advanced design patterns, and general best practices into account. And even when they do expose these aspects of front-end web development, understanding their significance within the context of users' interactions proves difficult. Not to mention, finding such tutorials requires a huge amount of effort that involves using overly specific search queries. Other resources like Stack Overflow often only provide isolated snippets of code without the context of a project's general structure and surrounding designs. So my research question then is, how can I use professional examples of front-end JavaScript components to help learners develop their own powerful components using best practices and advanced design patterns? So the pattern matching system seeks to explore this question by presenting a user with professional examples relevant to their component goals. Each of these code samples are paired with a video recording of the corresponding component within a browser that is being interacted with. That recording is synchronized with the timeline of the front-end code function calls, facilitating the component's lifecycle. So my hypothesis for the system is that using the pattern matching system allows users to understand the lifecycle of a component in addition to the component's developer's design choices. Users gain this understanding by seeing in synchronization recorded interactions with the component and the code that is run as a result of those interactions. This synchronized interaction code view affords users a different perspective on the structure of the component's code and insights into the lifecycle of the component as someone interacts with it. As a result, the new knowledge increases a user's ability to develop a similar component themselves within the workflow and context of their own project. So let's take a look at the actual tech. Alrighty, so the pattern matching system allows users to search for professional examples of components, first by filtering by component type. So we're going to go ahead and try to develop a draggable map, and then users are also able to order those results by selecting the technologies that they'll be using in their own project. So let's say I'm building a draggable map with jQuery. So if I were to want to, so looks like the best example. It has the highest confidence rating because it's both a draggable map using jQuery. So I clicked on that. And now we have three main components of the system. So there's the code view, the recording of an interaction with that component in the browser, and then there's the timeline component down here. So essentially what's going on in the timeline is that snippets of this code are broken down and their asynchronous relationship with each other are displayed in the timeline. So in the code, if I clicked on this, I'd be able to see a mouse down event being registered. Which then calls the drag function whenever that event's fired. And the drag function then calls the map.update function. So we can see those interactions in the timeline with the recording of the interaction with the component in synchronization. So I'm going to go ahead and there we go. So if I were to play this, you'd be able to see which events and pieces of code are being called in sync with the actual interaction with the browser in the code view. So that's the pattern matching system. To test my hypothesis, I recruited 5 users for a user study that each took about 45 minutes. The user study was split up into 2 parts. So, the first part, I provided each user with a context in which too many students are complaining about getting lost in tech, and the department's shelling out money to the student who develops the best solution. I asked the users to develop an interactive navigational tool for getting from room X to room Y on the first floor of tech, given an image of the floor plan and an object of room numbers and latitude and longitude positions. After asking them to benchmark their initial confidence in completing the task, explaining the pattern matching system, and giving a brief demo of how to use JSBin to develop their project, I gave them 30 minutes to complete the task using both the system and any online documentation materials. In the second part of the study, I gauged whether or not they were able to complete the project, and if they weren't, I figured out what the blockers were and how much work they had left. The remainder of the questions touched on the ways in which they used the pattern matching system, whether or not it helped them understand the life cycle of at least one of the professional examples, what that understanding afforded them with their own development, what they think the system lacked and why, and which extra materials would have been useful to complete the task. So going back and looking at all the results of the study, it seems as though the system itself worked to accomplish its intended goal. So every user was able to understand the life cycle of at least one component within the system and was able to explain in full how that component worked. Moreover, for at least one component, each user was able to take ideas about that life cycle, whether it be the asynchronous structure or DOM manipulations, and integrate those same ideas into their own work. In terms of what didn't work, a few of the components within the system were fairly compact in terms of code structure, and as such, the timeline of function calls was pretty shallow. So by that, I mean that this asynchronous call stack shown in the timeline was only 2 levels deep sometimes. Because of this, the affordances in the system were a little too weak to really contribute much of the understanding of those components' life cycles. Another thing that didn't work that well was that using the video recording, it was sometimes difficult to tell what was actually being done in terms of interactions. The cursor didn't give much information about whether the user was performing a drag or simply just moving the mouse around. Finally, since events fire very quickly, especially when they're triggered by dragging, users had a bit of trouble really mentally synchronizing the video recording with the timeline. Though the issue didn't necessarily affect their interaction with the timeline in the system, the affordance of being able to synchronize the recording with the timeline proved near useless in these scenarios. So, in terms of next steps, while I won't be continuing in DTR since I'm graduating, there's still plenty of work to be done on this project. More immediately, there needs to be the further enumeration of interaction experiences, in addition to the curation of corresponding professional examples in order to provide them within the system. Secondly, I believe that it would be fascinating to do some investigating into the tech feasibility of deconstructing individual functions into lower-level snippets of code that can be separated in the timeline of the system. Finally, the 2 most pressing research questions I am currently interested in are into what further categories can we break up the world of front-end development in order to match them with professional examples. So the 2 current ones in the system are components and interactions. The second question is, are there ways in which we can visually expose within the system JavaScript's direct effect on the DOM in order to further demystify components lifecycle? Thanks for listening, guys.